With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Two vessels of volume V1 and V2 containing the same ideal gas. The pressure in the vessels are P1 and P2 and the temperatures are T1 and T2 respectively. The two vessels are now connected to each other through a narrow tube. Assuming that no heat is exchanged between the surroundings and the vessel, find the common pressure and temperature attained after the connection. So we are given two vessels and gas is present inside them and they are connected with a hollow tube. If we consider both the vessels as part of a system, it is given that there is no heat exchange, therefore heat received Q is equal to 0. And also, since the vessels are assumed rigid, there will be no work output also. So work output will also be 0. So from the first law of thermodynamics, we can conclude that the internal energy change is 0 or the internal energy is constant for the system. Therefore, we can say that the internal energy after connection is equal to the internal energy of gas in vessel 1 plus internal energy of gas in vessel 2. So U1 is equal to U1 plus U2. U can be written as NCVT, where N is the total number of moles, CV is the molar specific heat capacity, and T is the equilibrium temperature, that is the temperature after mixing has been taken place, which is equal to N1 CV1 into T1 plus N2 CV2 T2. Since both the gases are the same type, therefore that CV will be the same. Therefore we can divide CV from both sides because CV is equal to CV1 is equal to CV. Now using the ideal gas equation PV equal to nRT, we can find the number of moles of gas. N is equal to PV upon RT. For gas in vessel 1, the number of moles N1 is equal to P1 V1 by RT1, and for gas in vessel 2, N2 is equal to P2 V2 by R. Putting this in the equation of internal energy, we get N is a summation of N1 and N2, so N1 plus N2 into equilibrium temperature T is equal to N1 T1 plus N2 T2. Rearranging, we get T is equal to N1 can be written as P1 V1 by RT1 into T1 plus N2 is P2 V2 by RT2 into T2 divided by, in the denominator we get N1 plus N2, which can be written as P1 V1 by RT1 plus P2 V2 by RT. R can be divided from the numerator and denominator, and T1 and T2 can also be cancelled in the numerator. So we get T is equal to P1 V1 plus P2 V2 divided by P1 V1 by T1 plus P2 V2 by T2. This is the temperature T after the connection has been made. Since the number of moles of gas is conserved, therefore we can write N is equal to N1 plus N2. Now N can be written as PV by RT. N1 can be written as P1 V1 by RT1 plus N2 can be written as P2 V2 by RT2. R can be divided from both sides. PV is equal to P1 V1 by T1 plus P2 V2 by T2. Taking this T to the other side, we get P1 V1 plus P2 V2 upon P1 V1 upon T1 plus P2 V2 upon T2. We can divide both these terms. So we have P is equal to P1 V1 plus P2 V2 divided by this V can be taken to the other side. We get V1 plus V2 because V is equal to V1 plus V2, because we are taking the assumption that the vessels are rigid. There is no change in the volume of the vessels. Therefore, this is the expression for the pressure after the connection is made.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.